What do we have here? Yeah, two apples, looking very similar. But to find the difference between them, one has to take a closer look and study them. Welcome to a new Cube video, and in this video I present you another CubeGUI plugin, CubeDiff, which allows you to study the difference between between two different measurements. Let's do it.
Hi everyone and welcome back to Terminal, and in this video I demonstrate you another CubeGUI plugin, this time context-free plugin, so-called CubeDiff. This plugin allows you to examine the difference between two different measurement results. As it states, you use this plugin to see the difference. How one would do that normally if one doesn't have this plugin. So for that, one would probably open a measurement. Let's open one. Like see here, profile 1. So we see this typical result, matrix, call tree, and then we open the second measurement, which we did perhaps with slightly different parameters, maybe with puppy counters or something else, and you would like to see if there is any improvement, regression, or change in execution. So normally you would probably open the two cube files, synchronize them completely like it is already presented in one of the videos, and you would go then from metric to metric. So like for example here, visits 2, 6 to 4 seems to be identical, so nothing has changed. Here is the timing, 13.4 in total, here is 12.9, so obviously there is some difference. So if we examine it, we see that perhaps here is the difference, 8.9, here is the 9.2, here is the minimal difference, here is some difference, here is some difference, here is slightly different, and particularly in MPI rank 1. Rank 2 is also different, and so on. So you would see that number of puppy counters has changed. So here is how much is that? 10,182,000. Here is 10,142, and so on. One can see easily that it is possible to examine multiple cube files, and they are different, but that's quite tedious. So in order to simplify this process and actually to show the difference at first glance, there is this CubeDiff plugin. So let's take a look how this very same procedure would be very easy and simpler. So for that we start the cube again, and we just see here, open context-free plugin. One of these plugins is CubeDiff. I have presented in a previous video that CubeGUI supports not only normal plugins, which work on some context of a particular measurement, but also so-called context-free plugins. It means they are meaningful without having any result open. Their result is usually a cube file which one displays in CubeGUI. So let's take a look. We execute CubeDiff and we see that we have some buttons. So we can obviously open cubes for examination remotely if we are operating some cube server. We skip that currently. So one can choose two cube files and one can get some options. Let's choose some files. Let's do trivial case. We see the difference between the very same files. It should be empty, 0 basically. So we just choose one file. Let's go here, for example this, and we choose very same file. Of course the difference has to be 0, right? So and we show the difference, and then we see it calculates the cube file. It builds very same identical call tree, it builds the same system tree, and makes element-wise comparison. So basically for every metric, for every call path, for every location, here master thread, it compares the value in one cube and in another, subtract, and then presents it here. And we see that all metrics are identical up to these two. These are special metrics. They have operation, the aggregation operation not plus or minus, but min and max, and therefore the difference between minimas or maximus is performed not via min, minus and plus, but via min max, and therefore there is non-zero values. But of course this is trivial. So let's take a look in a normal case. So we start again. We choose the one measurement result. In this case, let's see, it's profile 1, and we choose the another one which was running with slightly different parameters. Let's take a look. Where is the difference? It seems to be that these are two identical configuration, therefore we don't need to do anything specifying these options. I will come to these options a little bit later. So let's take a look at the difference. And we see that there are differences. So zero difference in visit means that every call in our call tree has been executed identical or the same amount of time. So execution in its structure, let's say, was identical. So that's already good to know. But we see the timings are now different, and we see that the some timings they dropped, so we have negative values, and some timings they increased, so we have positive values. We see that here negative values are suppressed and positive values are raised. So in this way we can visually see the difference whether it got up or got down. Of course, if the second measurement was improved measurement, then we would like to see here only negative values, but it's not always possible. So, and in this you see that at first glance where is the actually difference, and we see that this difference is mainly in rank 5 and rank 4 and rank 0. So then one has to study what's so special at this ranks, why the this execution at this ranks took different time. We can see also that the number of cache misses has changed, and accesses, and number of total instructions. So obviously there is a difference in configuration, and that led to difference in the time. Okay, additional options. So sometimes one performs two measurements, but not inside of one job script, but launch a second measurement a little bit later, and scheduler allocates job differently than before. So let's take a example. So let's go here. So that's one example of so-called Scalasca measurement. The Scalasca produces a lot of metric, there is some call tree, important is system tree. So we see that it was running on machine, Linux, general machine, but nodes are named. So that's JRC0054, JRC0055 with 2 MPI ranks each and 6 OpenMP threads each. All right. So that was some measurement with TM set with puppy counters. And later on, one made a similar measurement without puppy counter. So let's take a look at the scout, and we see that it's very same metrics here, the same measurement, but we see that the nodes are called 0049 and 0050, even if in a structure it's pretty much the same, but the scheduler allocated job differently, and now we have de facto incompatible measurements, because the node GRC0049 is the not node GRC0054. So strictly speaking, it's meaningless to compare them. But really, strictly speaking, logically, the configuration is the same, nodes are the same, or maybe it's very similar. So one would like to make this comparison. So how we can tell the cube to do this comparison? So for that, we actually can open this cube files, and let's take a look. That is let's say no puppy scout, and we go for puppy scout. So if we just try to make the difference, cube detects that system trees seem to be incompatible, so it cannot just perform plain difference between one cube file in cube measurement and another cube measurement. So therefore, what we do, we can say collapse system dimension, which in this case means it will recreate generate artificial system tree, name it unified, and based on this unified new system tree dimension, it will try to make the difference between this cube file. So let's see what is the result. We can click and we see that there is a result. We see that many metrics stayed the same, some of them have changed. There is obviously some reduction in runtime. But what about the system tree? So it shows that it created one virtual machine, it created one virtual mode, and we see that there are not anymore two modes to each MPI ranks, but there is only one virtual node, and there are MPI ranks. So we know that MPI rank in one measurement, that was the rank 49 something, MPI rank 1, it was very same node, and MPI rank 2 and 3, they were different nodes. In this way, we remove this difference in the just naming, and we compare the structure of the measurement. In this way, we can examine actually the difference in the run. So remember, collapse is needed when you have very incompatible system tree. What about this reduction option? So if we take a look here, so what about this reduced system dimension? That is a special case. So let's see. I will try to explain you. I'm afraid it will be hard to explain, but let's see. So let's take a look. A similar measurement. Let's do a reduction of system dimension. Show the difference, and we take a look. We actually don't see the difference in this particular case. But what does this reduction of system tree dimension is actually doing? Very often one makes measurement in a machine which has a really high hierarchy. So in this case we have a machine Eureka. It has the nodes, they are named GRL06, and then we have already MPI rank. Some other machines, they have way deeper hierarchy in nodes. So like for example, it might be a rack, it might be midplane, it might be node, it may be I don't know what, the cabinet. So one has then the system tree which maybe has the same structure of measurement on very low level. So basically every node has 8 MPI rank, but between these nodes are also clustered or gathered together as midplane, cabinet, and so on. They build a higher the tree structure. So with this reduction, Cube removes all this intermediate tree structure and leaves only the name of the machine. It gathers the lowest level of the node, so that MPI ranks are the third level of this tree, and in this way it maps measurement to measurement, and that is possible to make a difference. Unfortunately, I don't have proper measurement to display you, but hopefully this very clumsy explanation gives you idea. Try it out if you have a machine which has bigger structure, bigger hierarchies in this case, and then you will see the difference. So I hope you understood how CubeDiff is actually working. And if you have a question, put them into the comments, give us a like, subscribe, and see you next time when I will demonstrate another context-free plugins.